4.7 solar radiation and Earth seasons. Note. Insolation, which is the amount of solar radiation, which is energy from sun rays reaching an area measured in watts per meter squared. And then the learning objective for this 4.7 is explain how the sun's energy affects Earth's surface. And then solar intensity and latitude, which is solar intensity of insolation, watts per square meter, depends on the angle how directly rays strike Earth's surface, amount of atmosphere sun's rays pass through equator, and is more horizontal. And then equator equals higher insolation, then higher latitude. Here's an image which is sunlight strikes Earth at perpendicular angle, 90 degrees, which is to the equator, and then sunlight strikes Earth at oblique angle, which is in the north. And then here's a little image, which is the oblique angle, and the 90, which is the equator. And then solar intensity and season, which is orbit of Earth around sun and tilt on axis changes angles of sun rays. Causes varying insolation, varying lengths of days and seasons. Tilt of Earth's axis stays fixed during orbit. June and December solstices, and now north or south hemisphere is maximally tilted toward sun, which is summer or winter. And then March and September, which is the equinox, which is north and south hemisphere equally facing the sun. And then here's an image that represents that, which is when the sun's hit, which side doesn't get as much sun, and the shaded parts is that part. And then the tilt of Earth's axis causes variation in angle of insolation, which changes intensity of how the sun hits it. And then the length of day, which could make a day shorter or a day longer, which the sun rises earlier or later. And then the season, which would be winter, summer, etc. And then albedo, which is another note, is the proportion of light that is reflected by a surface. And then surfaces with higher albedo reflect more light and absorb less, which absorb less heat, which is ice and snow. And then surfaces with low albedo reflect less light and absorb more, for example, water, and absorb more heat. And here's an image of how when it hits snow and ice, it reflects 90% up and then 10% down to the water. And then the other way is when it's water without snow or ice, it goes 94% to the bottom and 6% to the top of how it reflects the heat. And then albedo surface temperature, albedo and surface temperature. Surface temperature is affected by albedo. When sunlight is absorbed by a surface, it gives off infrared radiation heat. Areas with lower albedo absorb more sunlight, light heat. Urban heat island. Urban areas are hotter than surrounding rural areas due to low albedo of blacktop. Polar regions are colder due to higher albedo there. And then the FRQ, which is identify which season is taking place in northern hemisphere in the diagram. Describe how the tilt of the Earth's axis is responsible for Earth seasons. The tilt of the Earth's axis is responsible for the seasons. So due to the diagram, it will be fall in the northern hemisphere during this time due to how the Earth is tilted during that time. And those are all my notes for 4.7.